Sauce here. This is a video lesson for Python programming, Bouncy. This is a project. I'm going to show an example of a project that accomplishes all the objectives, then read the objectives for the project that we saw and reflect on how the project accomplished the objectives. The main task for this project is to make a screen full of animated bouncing balls. Let's see what that might look like. Here we have a graphics window, and there are many circles, we could call them balls, that are bouncing off the edges of the screen. There's a line in the center of the screen, and when the balls touch the center line, they turn a dark color, a very dark gray, not black. There are about 50 circles. Some seem to be traveling on top of others. They are red and white and of different size. They'll also periodically start again in the center. Let's take a look at the objectives for a program like this. Objectives: begin this program with a stub file, stub0. So we don't have to write the essentials of all animated or graphics programs. We can start with a stub. Use a Pygame graphics window, not full screen. So there was a border of my operating system behind the window. It was not in full screen mode. Use a class to make a minimum 20 instances of a ball. Use a dictionary to manage them. That was done in the code file. There were more than 20 instances of my ball, which looks like circles. There were probably about 40 or 50 of them. 20 is a minimum. If you have a slow computer, then you might want to keep it at the minimum. If your computer is fast, it's fun to see more than 20. Draw the balls on the screen as colored circles. There are red and white circles that change color at the center line. They don't need to be different colors. They can all be the same color if you wish. Animate the balls by making them move in 2 dimensions, both horizontally and vertically at the same time. So we get this effect of traveling on an oblique by a vertical change and a horizontal change happening at the same time. Make the balls bounce off the edge of the screen. The effect must look realistic and intuitive. So we'll take a look at it again, but realistic and intuitive means that when the ball approaches and seems from the user perspective to touch the edge of the screen, that's when it bounces. And it bounces off the edge of the screen at the same angle that it came into the screen. It's like physics, the angle of incidence is equal to the angle of reflection and vice versa. The ball did not look like it went past the edge or smudged part of the circle into the edge before the bounce. The ball didn't bounce when the center of the circle reached the edge of the screen, and it didn't bounce before it looked like it got to the edge. The math made it so that it bounced at a realistic, correct time. Make the balls interact in some way with their position on the screen and make this interaction easily observable by the user. There's a lot of latitude here. In this example, there was a white line that was drawn at the center of the screen. It was a vertical line. And when the circles got to touch that line, they would pass through. They wouldn't bounce on the line. But if they were ever touching that line, then the color of that circle became dark, very dark gray. And then once it passed the line and was no longer touching it, it turned back to its original color. We'll take a look at this again to see some of those details of realistic and intuitive and the interaction. Here we have the many circles, and if we focus on how they bounce, it's quite quick. We can be convinced that it looks to the eye that they bounce as soon as the edge of the circle touches. And the angle that it bounces at is equal to the angle that it reflects. The center line, if we can focus on that, is what the ball's position is interacting with. There could be many interpretations of how to do that. It's very, very difficult to program so that the balls, when they collide will bounce off of each other realistically. That certainly can be done, but that is so challenging I would recommend not trying to work that out. It is much easier to work out, if you wish, when the circles are on top of each other. So they might not necessarily bounce, but one really nice effect to see is if you have two circles and they are on top of each other, they could change color or swap colors as they pass. But realistic bouncing like pool balls is very difficult to manage well. Okay, to finish up, reminders of coder-friendly files and user-friendly programs. Coder-friendly, as always, comments must be used to highlight each chunk or section of the code. For example, a comment for where balls are, the code for moving the position of the balls is maybe a highlight, or a comment where the code for bouncing is in your program, drawing them. In a stub, the stub should have comments already for the sections of the code that the stub includes, like the section where constants and booleans are located, or when the screen settings are accomplished, definitely where the frame loop starts. Those comments should already be part of the stub. Keep them. Add more comments as you code. Use lots of space to easily find and distinguish different sections of the code and comments. Use descriptive names for variables, for example, radius instead of r, x position instead of x, direction instead of d. Using x position instead of x might feel like it's a little bit cumbersome because x is already a very familiar variable for coordinates in the coordinate system in algebra. However, the coordinates for the positions of things are so common when programs get sophisticated that various names instead of just x, various names associated with x position could be used. So descriptive values like x position or x position circle, x position rectangle, x position button, all of these are very good examples for x used in various different ways when there are many things going on. So get in the habit, it's a good idea. Keep line lengths under 80 characters, never longer if it can be avoided. Break your lines at commas. If there are commas in your line and it gets to be long, then that's right after the comma is the best place to break your line so it can be legible without having to scroll. And under user-friendly, there's no user action in a program like this, but at a minimum, use the window title to display the authorship, who coded the program, and maybe the title of the program. You could call it Bouncy. Have fun.